Okay, today we're going to be looking at determining the polynomial when given the zeros. So consider these two polynomials, f of x and g of x. And think about these two questions. Are the polynomials equal? And what do you notice about their zeros or factors? So pause this and think about that for a minute. Are the polynomials equal? Well, the answer to that is no. Right? And the reason why is because this 2 and the 6 are not equal. What do you notice about the zeros or the factors of the polynomials? Well, what you should notice there is that they are the same. So what I want you to understand by looking at this is that just because two polynomials have the same zeros doesn't mean that they are necessarily the same polynomial because of this constant up here. Okay, so zeros alone cannot determine a polynomial, and here is my general factored form of a polynomial of degree n. It basically says we just have a constant up front and then each of our factors. My directions say to determine a polynomial function f of x of lowest degree with real coefficients and having the given zeros. One thing I want you to notice is that my directions say to determine a polynomial and not just the polynomial. So why am I saying to determine a polynomial and not the polynomial? So let's give you a minute to think about that. And it's because that I can have a constant up front which will make the polynomial different, but it would still have the same zeros. In problem 1 here, I'm given the zeros of -1, 2, and 3. So I know my general form for this function is going to be some constant a times x plus 1 times x minus 2 times x minus 3. So I'm going to take these first two factors and multiply them together. So I'll have x squared minus x minus 2. And then I'm going to multiply the x minus 3 times the x squared minus 2. And if you need to, you can come over here to the side and do your scratch work. And when I do this, I like to have my binomial first and then my trinomial. And what I'm going to do is to distribute this x. So x is going to be multiplied by the x squared, by the x, and by that -2. So I'll have x cubed minus x squared minus 2x. Now I'm going to distribute this -3, and it's going to be multiplied by the x squared, the minus x, and the minus 2. And I'm going to write those terms underneath these terms and line everything up so it'll be easier for me to combine my like terms. -3 times x squared is -3x squared. -3 times -x is positive 3x. -3 times -2 is positive 6. And then when I add that together, I have x cubed minus 4x squared plus x plus 6. Okay, you can see here I've distributed the -3 and combined my like terms, and I've got my answer here of x cubed minus 4x squared plus x plus 6. So I wrote that over on the left side of the screen with that a being the leading coefficient. Some of the problems in my math lab are going to have you to have this for the answer, but then some of them are also going to tell you that the leading coefficient is going to be 1 or -1. So let's say my leading coefficient is 1, then my final answer is just going to be x cubed minus 4x squared plus x plus 6. Okay, problem 2, I'm given my zeros. So I know that my function is going to be some constant a times x minus that 0 of negative 2 plus 3. Well, what I'm going to do actually here is go back and erase that parentheses, and I'm going to put in a bracket because I want to put this 0 of negative 2 plus the square root of 3 in parentheses. You need to remember that anytime you're subtracting something with two terms, that thing that you're subtracting needs to have parentheses around. Okay, my second factor is going to be x minus parentheses negative 2 minus the square root of 3. My last factor is going to be x minus 1, and I'm going to go ahead and put that in brackets just so I can have all of my factors in brackets. I could have put this in parentheses, but I think that just looks kind of weird. So now what I'm going to do is to drop the parentheses and distribute this negative sign. So I have x plus 2 minus the square root of 3. And then in my second bracket, I'm going to have x plus 2 plus the square root of 3. And in my last bracket, that's going to stay x minus 1. Now from here, there are several things that I can do. What I'm going to do is sort of a trick to kind of help us save a little bit of time. I'm going to group this x plus 2 together here and here. And so what I want you to see is I have this x plus 2 in parentheses and this x plus 2 in parentheses. They're the same. Then I have a minus square root of 3 and a plus square root of 3. So what I have here are conjugates. Well, we know that when we multiply conjugates together, the middle term cancels out. So when I multiply x plus 2 times x plus 2, I have x plus 2 quantity squared. The outer and inner terms cancel out, and then I have minus 3 for that last term. Now I'm going to go ahead and multiply out the x plus 2 squared. Okay, now what I need to do is to simplify what's inside this first set of brackets, and I'm going to change from brackets to parentheses now. X squared plus 4x plus 1 in the first set of parentheses. And then I'm going to distribute. I'm going to multiply everything in this first set of parentheses by x, and then multiply it all by negative 1. Now I just need to clean this up by combining my like terms. And there we have our answer. On this next problem, the directions say to determine the polynomial function of lowest degree with real coefficients at having the given zeros. So now there's going to be a specific polynomial. I'm not just given the zeros, I'm given a little bit more information here as well. I also know what that function value of 5 is. Okay, so the first thing I'm going to do is write out the general form for the answer, which is going to be a times x plus 3 times x minus 2 times x minus 4. And then I'm going to try to figure out what a is. Okay, now what I'm going to do is use this information that p of 5 or f of 5 equals 48. So remember, this 5 is my x term. So 5 is going to go in place of all of these x's over here, and this 48 is my function value at 5, so p of 5 or f of 5. So 48 is going to go in place of that f of x. So what I have is 48 equals some constant a times 5 plus 3, 5 minus 2, and 5 minus 4. So 48 equals some constant a times 8 times 3 times 1. So 48 equals 24 times a equals 2. So back over here, my function is going to be 2 times x plus 3 times x minus 2 times x minus 4. Okay, that was problem 3. So let's go on to problem number 4. Okay, here I'm given some zeros that are imaginary numbers, and I'm given the function value at -1 is 15. So let's go ahead and write down the general form for that equation. Okay, there I have the general form for my function. I'm told that p of -1 equals 15. So I'm going to put -1 in place of all of the x's, and 15 is the function value there. So that's the f of x. When you multiply this together, you can put it in the calculator exactly like it appears. Okay, so you're going to have 15 equals -30a. Then divide both sides of your equation by -30. This cancels, so a equals -1/2. So over here, I've got -1/2 times all of these factors, and I'm going to go ahead and multiply these two out. The x minus 2 times x plus 1 gives me x squared plus 4. And now I'm going to multiply out those two binomials. And then I'm going to distribute the -1/2. Okay. And that is my answer.